So this first example was a real life project that they did with FLAC years ago. We just converted it to FLAC2D. It was a landfill problem. It looks like this in 3D. I guess it was in New Jersey somewhere. In reality, you would probably want to do a 3D model of this. You can see how it's a real 3D geometry. They just did a 2D slice right down the long end of this thing. See what would happen. So there's this, there's a sand layer sitting on top of a fairly impermeable clay layer sitting on top of rock. And then you've got this landfill material. And then they wanted to build this slurry wall at the bottom here, which, I don't know, did some sort of filtering, I guess. But it turned out that adding this slurry wall actually right at the toe here was a problem. Clay looks like this. The material properties are here. These are imperial units. For this example, we actually converted it to metric because most of our guys like working in metric. It's certainly possible to run the model in imperial units, and I've actually done models like this for mines, where we just do everything in pounds per square foot. It's, if you're not used to, it's like, temperatures. If you're not used to thinking in Celsius, it's a little bit, just don't have an intuitive feel for it. So often what our own people do in our office is they'll do everything in metric. And then if they need to show the clients, they'll put the values of stress or displacement or whatever as extra variables and then show that in the plots, right? So you take your displacement in meters, multiply by 3.3, store it as an extra variable, and then plot that and say, here's my displacement in feet. And that's what we do all the time. And same with stresses. You could take the stress and divide by whatever it is, some number, to get the pounds per square foot stress, or even in the oil industry, they're like PSI. You could even turn it into pounds per square inch. Plot that as an extra variable and show it to people. Say, there you go, there's my stress. But anyway, we're going to do these in metric. That's just a close-up. We're not going to go into this much detail. And so this was before my time, but my understanding is that originally this was run with a limit equilibrium problem, limit equilibrium program. This looks like it might even be slide. They ran this thing, and they got a factor of safety of 1.04, which is a problem. And in fact, it was so close to failing that they were questioning how that's even standing up, because this thing is actually built. I mean, it's sitting there. And they're like, well, if the factor of safety is 1, how is it even sitting there? You know what I mean? It's like, that should be failing already. So there was a lot of doubt about the accuracy of this limit equilibrium problem. So they did a shear strength reduction problem with FLAC. And we're going to do that right now. But we're going to do it in FLAC2D. So this is kind of fun because it's a real life problem. It's got a bunch of layers. It's got water table. And in fact, we're going to end up with 2 water tables here because you have this fairly impermeable clay layer, which means that you have some water pressure up here in the landfill, and then you kind of have another set of water pressure down here, which is interesting. So whenever you try to do real life models, you realize that the stuff you've learned in the training course is maybe not necessarily going to get you all the way there. So it's useful to have this last day of doing these fun things. OK, so let's start FLAC2D. We're going to make a new project, and where you put it is important here because we're going to import a DXF, so you don't have to draw this whole thing. So put it in A3. We get there. A3, landfill slope. And see, there's a solution directory. Don't go in there. That's got the finished model. If we all get stuck, then we need to open the finished model. But don't go in there. Just put it in the landfill slope directory and make a new project and call it whatever you want, slope. Okay. We're going to start with a sketch set. So make a new sketch set, call it whatever you want, slope. This is not a super complicated geometry. We could draw it. It would probably take 10 or 15 minutes. But to save you that pain, we'll just import it. So click the little arrow going into the box to import background image and choose slope.dxf. There it is, drawn already. Then what you almost always want to do is click the one next to it, which is automatically create edges from the background geometry. The only reason it doesn't do that by default is that you may import something that's a picture or something that's like kind of a not perfect geometry, and you just want to trace on top of it. People do that. In this case, it's an actual DXF with actual points and lines, so we can turn it into sketch points and lines. Now, we could just zone this as it is, and we would get an unstructured mesh, because some of these are four-sided shapes and some of them are not. So remember we talked about on Monday, see this top layer here has a bunch of extra points on it. So even though it may be a four-sided, it thinks it's not a four-sided because it's these extra points, right? So we could either get rid of these points. If we wanted a structured mesh, we could either get rid of these points, or what we're actually going to do is just draw lines down from them to make four-sided shapes. And the reason for doing that is we're going to have different density of zoning in different parts of this thing. So breaking it up like that allows us to do fun things like that. So all we're going to do is go over here and choose the line tool, and then click on these points on the top and draw vertical lines down. Oh, if you hold down Control, it makes a vertical line. It doesn't actually matter if it's perfectly vertical. And it's OK to go past the end of the bottom, because we can just delete these at the end and get rid of those little hanging bits. So I'm clicking on the top points, holding down Control, going down to the bottom. In fact, you maybe even have to go past the end because it tries to snap to the grid and simultaneously snap to the line. You just go all the way down, holding down Control, then it allows you to draw this vertical line. It actually doesn't matter if it's perfectly vertical, but let's just try and do it. And then for the last one, see how there's this funny little toe thing going on here. What I'm going to do is draw down from these two bottom points here. So this one, you can see where I'm pointing here. I'm not going to worry about this one on the top. I'm going to go draw a line down from this one on the bottom. I'm going to draw a line down from this one right at the tip here. And what's going to happen is there's going to be one shape in here which is not four-sided, this little toe bit here, which is actually a five-sided shape. And it's going to end up with an unstructured mesh, and that's fine. Who cares? So in the end, I drew 1, 2, 3, 4, 5, 6 lines. And then what I want to do is click this little arrow so I can select things, select these hanging points, and just click delete. So we can delete those little line segments that we don't care about. Oh, I missed one. Look at that. Okay, so the thing that we imported was just the slope with the landfill and the layers. It does not include the slurry wall, which they want to put in and test. So we're going to have to draw that in ourselves. So what we're going to do is we're going to draw a vertical line at 170. So you can zoom in here onto the, well, zoom in somewhat to the toe region here. If you zoom in enough, you can see that the grid goes by tens. So now I've got on the top 160, 170, 180. So I can go and choose my line tool again. Click on the top at 170. It's not snapping to my grid here. Oh, I see. If I put my mouse over here, the line turns green. So I can click that, hold down Control. I don't even need to hold down Control this time, because it's snapping directly to the grid at 170, and then click on the bottom. So hopefully that worked for you. Hopefully it snapped to the top at 170, and you draw a vertical line down, and it snaps to the bottom at 170. And then we want to do the same thing at 172. So each one of these tick marks is 1. So I need to go 2 tick marks along here. And I'm going to go down. Oops, I need to zoom out a bit. The bottom. Oh, and look, I missed a line there. I didn't go all the way to the bottom of my first one. Fine. Okay, so hopefully you have 2 lines here, 2 vertical lines at 170 and 172. You can actually check. I mean, it doesn't matter if we're off by a little bit, but you can check if you click the selection tool and click on one of those points. It'll tell you its coordinates over here on the right. 170, 1.5. I'm sure you talked about this already, but if you mess something up, you can always just go undo, let it undo, Control Z, undo, 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 and then draw it again. It doesn't have to be perfect. In fact, the real slurry wall in this thing was not at exactly 170 and 172. I just used those numbers to make it easier to draw it. They were slightly different numbers. So, if for future reference, if you wanted to put a line down here that was not exactly at 170, let's say it was 169.7 or something, it's not going to snap to the grid. So what I would do, there may actually be a better way to do this, but I would go here and I would choose point. I would just stick a point somewhere and then change its coordinates. So click on the little arrow, click on the point, manually type in its coordinates over here. And then you can draw a vertical line down and all the other points will line up, right? Okay, I'm going to undo that. Okay, and then the last thing we need is the slurry wall doesn't go all the way down into the rock, obviously. It goes part way down into the clay. So we need another horizontal line here that represents the bottom of the slurry wall. And so we could just draw a little line here between 170 and 172 for the bottom of the wall. But if we want everything to be structured, 4-sided shapes, we'll just draw it all the way across. So what we want to do is draw a line at y equals -10 all the way across. And so there's a couple ways you could do this. Again, like I said, you could start by just drawing a point somewhere on the left side. Because it's a bit hard to zoom in enough so that it's snapping to the grid, but then draw the line all the way across the whole thing, right? So if I just draw a point here at -10, I'm just going to make sure that it's actually at -10. So yeah, position is -30, -10. I drew a point on the left side here. Now I can zoom out and see the whole thing. Okay. Go back to my line tool. Click on that point I just drew, hold down Control, and go all the way across to the other side. And maybe even out the other side, as mentioned before. and then delete that dangling point. Did everybody get that to work? I mean, you could, in theory, just go segment by segment here. Draw a line in this first block, and then a line in the second block, and a line in the third block. If you can't sort of zoom out and see the whole thing in one shot. Okay, do we all have a line at -10? Okay, we're done drawing lines. Now we're just going to zone it. So go to your little zone tool here and choose auto size. And in the drop down here, choose model extent. What we're going to do is, instead of specifying a zone size, we're going to specify how many zones we want across this whole thing. So let's say we want 120 zones across the extent. Say OK. Now, click on Mesh All Blocks. Now, what happened here is something weird. You saw when we had the little red X's on here, there was a whole bunch on the left-hand side here. So it looked like it was going to make me like 20 zones on the left side here. Because it's trying to make a structured mesh, it didn't do that. So down here in this little area here, the zones are the right size. And in order to keep the structured mesh, it's saying, OK, well, I've got 2 zones here that are the right size. And I need 2 zones here, and 2 zones here, and 2 zones here, and 2 zones here, and 2 zones here, so that everything lines up and remains structured. And so now you have something that is not exactly what you wanted. You have a nice structured mesh, but you've only got 2 zones in the vertical direction here, which is kind of wacky, right? So if you pulled it to be an unstructured mesh, that wouldn't happen. You would just get a full number of zones, and that would probably be fine. And we could do that, but just to illustrate the concept. And because this was based on a FLAC model, I'm trying to make it behave the same as the FLAC model, which had to have a structured mesh, right? In this case, we could have just said, make it unstructured, boom, and it would just do it. But if you don't tell it to be unstructured, it tries to make a structured mesh, and you end up with something like this. So then what we can do is we can just tell it to put in more zones here. So I can click on this left-hand edge. Say I actually want to have 5 zones here instead of 2. And so then what it does is it says, oh, great, I'll put 5 zones in here, 5 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 in here, but I don't know what to do here because it's not a 4-sided shape. So now all you need to do is go up here and say, mesh all blocks again. And it's going to do its best to make a mesh in here that matches the mesh on the left-hand side, but it's not structured. You can see what it looks like, right? OK. So we're OK with that for now. We're actually going to densify this a little bit later just to show you how it works. But for now, we're just going to set groups. So we'll go from the bottom to the top. So this bottom layer is rock. So we're going to call it rock. So you could go through here and click on each one of these blocks, hold down Control and click, Control, click, Control, click, Control, click. Or you can just draw a box around them. So if you can get your box in the right spot to pick these bottom blocks, right? You can just click over here to above and to the left of the bottom layer, and then just draw a box around the whole bottom layer. And it's a little bit tricky because these layers are kind of skinny. But if you can manage to do it, you can select the whole bottom layer in one shot like that. And over here where it says object properties, give the group name and just call it rock. Actually, in my example, I called it capital R rock, but I don't think it matters. And then the next 2 layers are the clay. Remember, we had to draw that extra line to demarcate the bottom of the slurry wall. But in fact, these two layers are both clay. So if you can try and do the same thing, draw a box around these two layers. Zoom in a little bit here to make sure that you've selected them. They should turn blue. If it's not working, remember Andre said yesterday, if I click a face and then try to select something, it's going to select all the faces, right? Or if I click a node and try to select the box of things, it's going to select all the nodes. But we want to select the actual zones, right? So what you need to do is click in one of these blocks first, so that it knows you want to select zones, and then draw a box around the region of interest. And we'll select all the zones, and then you can change the group name, in this case to clay. Okay? And if you can't get the drawing the box to work, I mean, you can just go and click these things one by one. It just takes a little longer. Okay, the next layer is the sand. This one's a little trickier because it's not a constant width. So what I'm going to do here is actually just draw a box around the left-hand part of this thing. Oh, I didn't do it right. I'm going to draw a box on the left-hand part. I totally messed that up too. All right, I'm going to do this one by one. I'm going to click this box, hit Control, click the next one, hold down Control, click the next one, hold down Control, hit the next one, click the next one, click the next one. These little tiny guys in here. I'm going to call them sand. So I'm selecting this layer here that kind of goes underneath this unstructured bit. Selecting all these blocks and calling them sand. And then I can do the same with the top. Again, it's not a constant thickness, so it's probably easier just to click the blocks one at a time. So I'm clicking the left one, hold down Control, next one, next one, next one, next one. These little guys here. So I'm going to call it waste. So now you can check you did everything right. See this funny little icon here, which is like a box with a dotted line around it. It says highlight groups. So you can choose none. Now go in there and choose clay. And it's going to highlight the clay layer as green, right? So you can see, especially if you zoom in on this area here, you can just make sure that you did everything right. And then you can click the same thing and choose rock, and it'll make the rock layer green. And you can choose sand, and it'll make the sand layer green. You can choose waste, and it'll make the waste layer green. And you can see, just verify that you didn't miss any little blocks. Because sometimes when you have little guys in here, you might not click on one of them, and it doesn't have a group name. So when you assign the properties, it doesn't get any properties. You'll get a warning. It's not a disaster. Okay, so we're done with that. You can click this little create zones icon. And it makes the zones. And now would be a good time to save it. So what I usually just do is go File, Save Project. And it will say, oh, would you like to save the model state? And I would say yes. And just call it like sketch or something. And again, I could go to this state record, right click on it, and save to a file. So it's going to take all those commands that were generated while I was doing all that clicky stuff and save it to a file, which is, again, useful. Maybe I want to go through and just change the coordinates of something or whatever. I can just go and change it in the file instead of having to redraw everything, right? We don't necessarily have to do that in this example, but could. Okay. Now, it made this nice structured mesh here, right? So it's got this 5 zones here in the pink, then 5 zones and 5 zones and 5 zones and 5 zones. 5 zones is okay down here, but up here, maybe they're a little bit big. Look how they're kind of long and skinny. Maybe I want to have more zones up here, but I don't want to have more zones down here. So how do I do that? Like if I wanted a true structured mesh and said, okay, give me 10 zones here, I'm going to end up with 10 zones down here, and they're going to be tiny little skinny flat zones, right? So what I can do is just densify some of them and not all of them. So if I click on the first one, the pink one, mine's pink, yours might be different. If I click on these top left 4 blocks here, so I'm clicking on the 4 top left blocks because I want them to have more zones in the Y direction. And then I go over to this little tool here, the rightmost tool, and choose the drop down and choose densify. Here I can densify, so I could, by default, it says, okay, I'm going to turn every zone into 4 zones. I'm going to split every zone into 4, right? 2 in the X direction, 2 in the Y direction. We don't need to do that in this case. We just need to split them in the Y direction. So you can say I want 1 in the X direction and 2 in the Y direction, and hit densify. And what should happen is it should turn the 5 zones in the Y direction into 10 zones in the Y direction. And it may or may not work because there's actually a funny little bug in here. But let's just see what happens. Right. So it turns out that there's a little bug where that it doesn't actually always know the difference between X and Y. So what you can see here is what happened is for these, well, at least in my case, it might be different in your case. It depends on how it was drawn. The middle 2 ones did what I wanted it to do. Went from 5 zones to 10 zones in the Y direction. The left one and the right one did the opposite of what I wanted it to do. It made double the zones in the X direction and not in the Y direction. So in the long term, we will fix that bug. In the short term, we can just hack it. So just go edit undo. Those things are back to being not densified. Now, click the first one and the 4th one and go densify and choose 2 in the X direction and 1 in the Y direction because it's backwards. And then choose the middle 2 and choose densify, 1 in the X direction and 2 in the Y direction, and we'll be okay. So now I have 10 zones in the vertical direction and a sensible number of zones in the X direction. And then what you can see here, zoom in on the toe here, I've got this mismatch, right? So here I've got 10 zones in the vertical direction, and then the green section here, I've only got 5 zones in the vertical direction. So I've got a little bit of a mismatch here, which is fine. FLAC2D can deal with that, which is one of the awesome things about FLAC3D and FLAC2D is that you can have densified regions next to not densified regions, and everything works out. We just need to add one command when we get to the files that says, join these things together to make sure that they're gonna work. But this is super handy. The ability to go in here, well, assuming that there's no bug, the ability to go in here and densify things is super handy. And actually, 99% of the time, people are densifying the same in the X and the Y direction, which is probably why no one discovered this bug yet. Because normally what you're doing is saying, oh, I've got a tunnel. I want more dense zones in here. Just take every zone and split it into 4 and go 2 by 2 or 4 by 4 or whatever. And so it's relatively rare that people densify more in one direction than the other direction. Which is probably why we haven't found it yet. But, well, we found it. We just haven't fixed it yet. Okay. So what this is showing by default is all of the construction blocks. So when we drew in Sketch, every single 4-sided block that was created in Sketch or 5-sided block gets its own color. This is not generally that useful. We want to color them by layers, right? Because we went to all that effort to give them group names. And so what you do is you go over here on the right-hand side, and it says slot any. Change that to slot construction. And that will show you the group names that we assigned in the sketch. So when we assign group names into sketch, they automatically go into this construction slot. The blocks that were created in sketch go into this block slot. So you can choose the block slot and see all the blocks, right? Block 28, block 29, block 17, block 3. Could be useful. Well, it was useful in the case of doing the densification because we only wanted to pick some blocks. But now we're assigning properties. Change that slot to construction. That will show the group names that we assign. All right. For this example, we're going to make everything more Coulomb material. So you can select everything by just typing Control A. Selects all. Oh, that totally didn't work. Why not? There we go. Control A. And all the lines should turn yellow, meaning you selected everything. And then I go up to my little tool here on the right and say assign a constitutive model. Here. And I'm choosing standard more Coulomb. You have to assign a constitutive model before you can assign the properties, because different constitutive models have different properties, right? I can't assign a over-consolidation ratio to more Coulomb material. It doesn't know what that is, right? So you always have to assign the constitutive model first. Now we can assign the properties. And so we could go through here and click on each layer and enter the properties by hand, which would take us, 20 minutes. And probably we'd make a typo because we'd mess it up. So what we're going to do instead is click on a layer here and choose from our little tool materials database. So I've actually put all these materials in a little mini database for you guys already. And so what you need to do here is go to import database. And by default, it goes to some location where you installed the software. What you want to do is find where we're sitting, where our project is, because that's where I gave you the database. So go to wherever it is that this project is. Landfill slope. I'm in the landfill slope directory, and there should be something here called materials.db. Yep. So choose that and say open. Oh, in my case, I'm overwriting stuff because I already did this at home, but hopefully yours will just import it. And then on the left-hand side here, you see this database of materials. Right now, all we have is more Coulomb materials, but if you expand that, there are materials associated with the landfill, which is this one. And there may or may not be other materials in your database. And so you could imagine a world in which you had a database of all kinds of different material properties for all kinds of different projects, right? Which is potentially useful. We don't necessarily want to have all of those different materials available in this particular model. We only want the landfill ones. So we can click on that landfill entry and say add to working set. And so hopefully you will now see on the right-hand side more Coulomb, which expands down to landfill, which expands down to clay, rock, sand, and waste. So now I can close that. So this was just getting the materials from the database and adding them to our project, essentially. I can close that. And now, again, if I click on the waste at the top layer, now I can go set material properties. And over on the left-hand side here, you can expand the landfill and choose waste. And choose copy to properties. And hopefully, your properties are filled in. Depending on when you copied the share file. When I originally set this up, the material property dialog had bulk, shear, Young's modulus, Poisson's ratio. And the reasons that I don't want to get into, the Young's modulus and Poisson's ratio disappeared. They will be back again. But for this particular version that you've got, there's only bulk and shear. So hopefully you have numbers there for bulk and shear. Density, cohesion, friction, and the other two are 0. And now I can just say save changes. Again, this is all metric. So these are pascals. And now I can do the same thing with the other layer. So this is easy. You just click on the sand layer, go set model properties. From the landfill, choose sand, copy. See the sand has a cohesion of 0. Save the changes. Same thing with the clay. See the clay has a friction of 0. And then same thing with the rock. Okay, we're almost done here. Almost done with this model pane. The last thing we're going to do is assign the face group names so that we can apply the boundary conditions later. So you remember this one, all you do is click on this little A. And I'm going to uncheck the assign face groups inside the model and check the box for ignore existing group names so that I just have west, east, bottom, top. If you don't check ignore existing group names, you have like west waste, west sand, west clay, west rock, which might be useful in certain circumstances, but in this case, we don't care. So check the box to ignore existing group names, say assign groups. And in fact, it's still slightly more complicated than we would like. You can see there's actually a West 1 and a West 2. And that's because of this funny little boundary here where the zones don't line up. Remember when we did the attaching. And so here it thinks it's a boundary and it gives it a name. So we just have to be aware of that. That there's an East 1 and an East 2 and a West 1 and a West 2. And you have to take note of the fact that this is actually called West 2 and this is actually called East 1. So when we come to apply our boundary conditions, we need to know that. You can, of course, just use coordinates when you're applying the boundary conditions. And in a lot of the simple models you've been doing so far, that works fine because everything is at x equals 0. But when you're doing real life models like this, often they're in some sort of mining coordinates or something. So it's not at x equals 0. It's at x equals minus 127.3. So using those coordinates is kind of a pain. It's easier just to say, give me the west side. Okay, we're done with all the clicky stuff here. So I'm going to save this again. I'm going to go File, Save Project. And I'm going to save the model state, and maybe I'm just going to call it model. Because now I've got the zones, the group names, the properties, the constitutive model. I don't want to have to do all that again, so I'm going to save it.